morning and welcome to episode number 5 of the ZoomTown Experiment. Now is when things will start getting more interesting. We're kind of moving beyond that point of theoretical introductions and moving into the real world. We'll have a brief overview of possible motor choices, primary factors for the motor choice, reasons why N20 is a good choice. That'll make more sense in a moment. We'll do some simple and practical testing. And finally, we'll provide an analysis of what we've discovered in this video. Being that it's time to get the Zoomies zooming around ZoomTown, and the only way they can do that is with a motor or motors. There are many sizes and types of motors available, each with its own advantages and disadvantages. Here are a few of the motors I have on hand that it could be a potential choice. Over here are a couple of larger stepper motors. These I would typically use in a much larger robot than what we're planning for the Zoomie. This particular device here is a windshield, a car window actuator. It rolls up and down your car windows. I've used these in a lot of projects over the years. This particular unit I got at a surplus store, American Science and Surplus, to be specific. It turned out to be junk, but nonetheless, it was one I've kept around just for getting scale and proportion. This is very good for robotics because they are a right angle drive. They're gear driven. And generally, they're pretty easy to adapt the drive output to a wheel. Here's a couple of really small stepper motors, and I did start out with, I believe it was this one, an early experimentation for the Zoomie, but it just didn't have the torque or speed combinations that I felt were needed. Continuous rotation servo motors. These are very, very popular in robotics. They work very well in some cases. This device here is another very common purpose-built motor. It's a gear reduction motor, and it's a right angle for robotics and other types of devices like that. These guys here are the N20 motors that we're going to probably be focusing on throughout the rest of this presentation. Here are some of the driving factors for a motor choice. Size must be small yet powerful. Power, the voltage within the range of the batteries or power supply that we're using for this device. Low current for longer runtime. This will be battery powered, so I don't want something that's going to be a power hog and drain the batteries quickly. It needs to be responsive, fast start and stop, and no run-on. Oftentimes, gear motors can have a substantial amount of run-on when you power them off. Performance. I need a good combination of both speed and torque to meet the needs. The Zoomie's not going to weigh a lot, so it's not going to be a high demand on torque, but speed is going to be something that we have to balance throughout the course of this entire experiment. Mounting. The device or the motor or the gear drive, whatever it is, has to be simple to mount. The more complicated the mounting is, the more probability there's a need for special brackets, etc., and that all drives up complexity and cost. Cost. We need 2 for each Zoomie, and likely this is going to be the most expensive components on the entire Zoomie. Well, based on that list, we can pretty much assure that this is too big, this one's too big, this guy's out of the question, this one is close, but it's still pretty big. RC servos, I've already mentioned those in a previous video where I didn't get the performance and responsiveness out of these types of devices to suit my needs for the Zoomie. Plus, the better quality ones, which would have performed better, were simply just too expensive overall for this project. So servos or continuous rotation servos are out of the question. As I alluded to a moment ago, I did start with, I believe it was this one, in early experimentation, but getting the performance out of it that I wanted for torque and speed was not a good option for that, nor was this one. And they are both geared down motors, etc., but they're just not delivering the performance that I would like. They would be very easy to control, being that they're stepper motors. I've used this type of motor in gear drive on a number of projects in the past. They work very good, but it is limiting for what I want in this experiment. Essentially, this is a single output. Speed-wise, yes, it's variable speed, but there's no change in the gearing. There might be a few different varieties of this, but you don't have a lot of choices with relationship to motor RPM and output gearing, and that greatly affects the performance. These N20 motors, once I discovered them, which in truth happened right at the start of this project, just are amazing me for all the potential in this design or style. They are geared. So you've got your little DC motor with a lot of gearing to give you various output capability regarding torque or speed. I believe there's about 10 or 15 different gear ratios you can get between the motor and the output shaft. That's an awful lot of control. You also can get various voltage inputs for the motor. I believe I saw 3, 6. We're going to be focusing on 6 volt. 9 and perhaps even 12 volt motors. So that's just a fantastic amount of options available to us throughout this experiment. Not only do we have an inline variety, but we have a right angle variety. This could come in handy for when running out of space on the width of the Zoomie. Now, right now, if we've got this motor, and we'll just put this one here. You start to see, here we go, how long this gets from end of axle to end of axle, or end of output shaft to end of output shaft. This is going to establish the width of the Zoomie if I'm using the inline variety. If I'm using the right angle variety, I could have a motor here and another one mirror imaging it with the shaft pointing that way. I could get the Zoomie very narrow, but then I lose area or space within the Zoomie with the motor going back this way. So this is one of the things I'm balancing right now, and I'm pretty much favoring the inline variety. It doesn't use a worm drive, which can be a little bit on the inefficient size, and this one does provide a lot of varieties. Here's another option that just blew me away, and this motor I bought from Adafruit. And it's actually got an encoder right here, so the encoder's built into it. Now, this option is expensive, but I still can get and arrange an encoder on this end of the shaft where the wheel will go. Now, here are some of the reasons why I really think the N20 is a good choice for us to use as our baseline, our starting point for this whole project. It's very compact. It's available from multiple sources, and that's important because that allows me to shop around and get best pricing. Remember, cost is a huge driver on this entire experiment. The N20 can either be inline or right angle drive, and that gives me much greater options with overall design of the Zoomie. I can get it in various voltage choices. That way I can alter what I want to use for battery supply. They come in various speed and torque choices, and that, of course, is related to not only voltage, but gearing to give us speed and torque. Some of them even include coders, but they can be costly, such as the one from Adafruit. It's going to be out of the price range for our project, but it sure is nice to know that that is an option for this tiny little motor. Easy to mount. Looking at the motor, it looks like it's rectangular in shape. I can clamp it between some pieces of plastic on the chassis design. Easy peasy, lemon squeezy. Cost is reasonable on this. So far, I don't want to go into pricing just yet because I got a little more shopping to do, but I'm quite certain if I go to AliExpress, I can get these even cheaper than what I'm seeing on Amazon or any of the other suppliers here in the U.S. Considering I'm going to need about 30, maybe 40 of these things, I do need to keep that cost in check. Now we're going to take a look at a little bit of practical testing on it. I've got the little motor hooked up to my lab power supply over here. And I've got a little wheel on here. This is one of our prototype wheels, 3D printed. It's got an O-ring for a tire and a piece of blue tape as a marker. And I'll use that in post-production with the video editing to calculate the RPMs as needed. I'm mostly concerned at about 5 volts and around 6 volts. But this will just provide a good way to observe the behavior of this motor. So we're going to start turning up the voltage till we get something happening here. Okay. It starts rotating at about a half a volt, a third of a volt. Very fascinating. So, comes up nicely, sounds good. Freewheeling, it's not even pulling any current yet. We're at 0.02 amps at almost 5 volts. There's 5 volts. Very quiet. Nothing objectionable there. RPM looks good. Motor feels cool. I'm going to take it to the rated 6 volts. There's our rated 6 volts. Still very quiet. Little teeny bit of vibration in it as you'd expect. I'm going to check the torque on it. To do that, I'm just going to stall it out. And that'll tell me a little bit about the maximum current draw too. Okay, about 0.23 amps, 230 milliamps, not bad at all. And it's torquey. It's definitely going to have more than enough torque to pull the Zoomie along, especially with 2 of them propelling it. All around, I'm really liking what I see. I've got a lot of torque. I've got decent speed. I'll get a good sampling here in video so that I can calculate it in video editing. That's 6 volts. I'll drop it down to 5 volts. And there's 5 volts, notably slower RPM. And I'm going to still about 250, 240 milliamps at peak load on it. So all around, pretty darn respectable. Well, that practical testing seems to look pretty darn good. This little motor is quite a surprising little package. Let's take a look at what we've learned from this video and how we can take that information and move forward with the Zoomie. Size, I would have to say, is a good size for what we're trying to do. It's very proportional to the overall size that I have planned. I'm running a 6-volt motor at 5 volts. The RPM is a little bit sacrificed, but overall performance is very good at both 6 volt and 5 volts. Current draw is very acceptable. I suspect we're not going to be running at full stall very often, so my guess is we'll probably be pulling about 30 to 40 milliamps typically while it's running around per motor. Performance for speed and torque, they appear to meet the needs. So overall, that part looks really good. Mounting is simple enough. Be easy peasy to put it in a chassis and mount it up in there in a number of different ways. Inline models will most likely fit our budget because I don't see any other really good options at this time. If I've got to go over to a right angle unit, I'm also hoping that will fit the budget. I'll try to update this pricing if it's available to me by the time I get this into editing. It may be difficult to control the speed accurate enough, but I really won't know until we get the whole thing built and we get the Zoomie moving around. I kind of got a hunch it's going to behave quite nicely from what I can observe so far. So far, this motor's been quite surprising to me. Performance is looking great, size is great, it fits within our budget. I think overall it looks like a real winner. But there's still another important test. I have to have a motor driver to drive this thing. So that's what episode number 6 is going to be all about, connecting this little motor to a motor driver. Hope to see you then.